Well, hi there. Thanks for joining me as we take a look at one of our first practice problems here for looking at probability for dependent events. We're going to take a look at problem number 10. So let's see what we got going on here. We've got a bag contains 5 red and 3 blue discs, or like little coins or medallions or whatever you want to call them, all identical except for the color. So first, Priyanka takes a disc at random from the bag, and then Jorge takes a disc at random from the bag. Okay, so we've got a bag, we've got people, they're pulling these little discs out of the bag. Maybe they're stuck at home and really bored and have nothing better to do. So this is what they're going to do. So complete the tree diagram. Okay, well, let's take a look at this tree diagram and see what's going on. So notice this tree diagram is labeled really well. So you've got Priyanka's disc. So Priyanka pulls her disc out first. And what are the possible outcomes that could happen? Well, Priyanka could get a red disc, or she could get a blue disc. Now notice I said or there. Notice both of these are connected to the same little vertex down here. Okay, so those two are connected to the same vertex. In this case, these are called complementary events because these are the only two things that could possibly happen. So we need to remember that probabilities are all of the little branches that are connected to the same vertex or the same starting point. They all need to add up to 1. So if the probability of getting a red disc is 5/8, well, what's going to be the probability of getting a blue disc? Well, if 5 out of the 8 discs are red, how many out of the 8 discs are blue? Well, you can even read from the problem up here. We know 3 out of the 8 discs are going to be blue. And notice these two add up to 1. So I'm put down here, if I have 5/8 and then I have 3/8, this is going to add up to 8/8, which is going to give me 1. And that will always happen for branches that come from the same vertex. So, okay, Priyanka chooses her disc, and now it's time for Jorge to choose a disc. But notice there are different scenarios that could happen. Priyanka could choose a red disc, and now what is Jorge going to do? So Jorge could now also choose either a red disc or a blue disc. So they're giving us that Jorge's disc, the probability of choosing red, is 4 out of 7. But hold on, aren't there 5 red discs and 8 discs in total? So how did Jorge get a 4 out of 7 probability of choosing red? Well, we need to remember for this path tells us that Priyanka took a red disc out. So she already took out a red disc. Let's see here. If I have red, I'm going to pretend this is red. So I've got 1, 2, 3, 4, 5 red discs. And then I've got 1, 2, 3 blue discs. Well, Priyanka already took one of those red discs out. She's got this red disc sitting in her hand. Well, okay, how many red discs are left? Well, notice there are 4 red discs left, 1, 2, 3, 4. And how many total discs are there in the bag now? Well, 1, 2, 3, 4, 5, 6, 7 total discs. So that's why Jorge's disc is now a probability of 4 out of 7. Now, again, these two branches start from the same vertex. And what did we say about vertex? The branches that start with the same vertex, we said these probabilities have to add up to 1. So if there's 4 red discs out of 7 total discs, how many blue discs are there? Well, 4 of them are red. That means 3 of them, 3 of the 7 are going to be blue. Okay? So now let's look at the last little bundle of branches here. Notice this means Priyanka chose a blue disc. So if we started out with 1, 2, 3, 4, 5 red and 1, 2, 3 blue, well, now, this time, we're assuming that Priyanka chose a blue disc. So now, one of the blue discs are gone, and they've been taken out. So now, I want to know, of the remaining discs, what's the probability of getting red? Well, I've got 1, 2, 3, 4, 5 red, because I didn't take any red out. Priyanka took out a blue, not a red. So I still have my original 5 red. And how many total discs are there? 1, 2, 3, 4, 5, 6, 7 total discs. Because again, this blue disc was taken out. So now again, we have the same vertex, which means these two probabilities have to add to 1, which means this is going to be 2 out of 7. Okay, so we know 4 out of 7 plus 3 out of 7 is equal to 1. We know 5 out of 7 plus 2 out of 7 is going to equal to 1. So anytime you have branches with the same vertex, that's going to equal to 1. Okay, I'm actually going to stop this video here. We're going to go in pieces so we can do little bite-sized chunks. So that is how we're going to fill out the tree diagram for this. So now that you have the tree diagram, try the other parts. What do we got, B and C? Try parts B and C. See if you can use this tree diagram to do parts B and C. And if you get stuck, check out the next video and I'll go over parts B and C.